Hey guys, welcome back to my CCNA 200-301 course. In this video, we are going to review decimal to binary conversion and vice versa, which is a necessity for IP version for subnetting, which we will talk about it later in next videos. Are you ready? Let's get started. Mathematically, if we want to convert a decimal number to a binary one, we need to do consecutive divides. For example, if we want to convert 191 in decimal basis to the binary version, we need to divide 191 to 2. And then we write down the quotient and the remainder. After that, we again divide the quotient to 2. And again, write the remainder. And this process continues until we reach to a point that the quotient is not divisible to 2. And then we write down the last quotient and the rest of the remainders backward, like the one you can see in the slide. And then we will have the binary number. But this method of conversion is a bit time consuming and there is always a chance of human error unless you're using a calculator. So I want to introduce you a simpler way of doing this conversion. For this simpler way of conversion, we need to consider a reference byte. You know that each byte is consisted of 8 bits. And the value of each bit starts from 0 to 7 from right to left. So we got the least valuable bit on the right side and the most valuable bit on the left side. And the value of each bit in decimal is 2 to the power of the value of the bit. So for the first bit, it would be 2 to the power of 0, which is 1. For the next bit is 2 to the power of 1, which is 2. And then 4, 8, 16, 32, 64, and finally 128. If we sum all these numbers together, the result will be 255. So the biggest number we can have for each byte is 255. There is a very simple connection between these numbers which can help you in IP version for subnetting. And that is, the value of each bit is the value of all the bits prior than that plus 1. So for example, for 8, it is 4, 2, 1 plus 1. For 16, 8 plus 4 plus 2 plus 1 and plus 1 again. This would be very helpful for you. You'll figure it out later. Now we want to use our reference byte to convert 191 to binary again, so we can compare the results. To convert a decimal number with this reference byte, we have to start from left. And we have to ask ourselves, is there any 128 available in 191? The answer is yes. So the value of 128 for 191 in binary would be 1 because we got it. Then we have to decrease the value of our bit from the decimal number. So we actually decrease 191 by 128 and the result is 63. Next we go to the next bit, which is 64. And then we ask again, is there any 64 available in 63? The answer is no. So the value of 64 for 191 in binary is 0. So we cannot decrease the value by 64. Then we go to the next bit. And then again we have to ask, is there any 32 available in 63? There is. So we put a 1 again and minus 32 from 63. And we continue this process until we reach out to 0, which means we don't have any remainder. So we actually do it one by one, bit per bit, until we reach out to 0. If you reach out 0, before reaching end of the byte, obviously the rest of the bits values would be 0 because you don't have anything to do the decrement. So the rest of them would be 0. We can use this reference byte to do a binary to decimal conversion as well. How? You can simply multiply the binary numbers to the decimal value of each bit and accumulate the results. So for this number, we have to multiply 1 to 128 plus 0 to 64 plus 1 to 32 plus 1 to 16 and continue to the end, and the final result should be 191. I want to give you a homework. Convert these numbers from decimal to binary and then check your work from binary to decimal. 240, 172 and 82. If you are a novice learner, I would strongly recommend you to practice this method with some random numbers you choose as well. Alright, this was our today's video. I wish you enjoyed it. If you enjoyed it, please do not forget to click on the link above and subscribe the channel, like the video and put your comments down below. Thanks for watching.